Hello everyone. In this video, let's discuss about the capacitor, s- switched capacitor circuits with the fixed DC input voltage. Here you can see there are two switches S1 and S2 which are being switched in this way. So this is like first S1 is turned on, during that time S2 is turned off, then S1 is turned off, then S2 is turned on, then S2 is turned off, then S1 is turned on. Okay, this kind of sequence will continue till infinity time. Okay, and here we can say that this is a V in, which is a fixed DC volt to V volt, and we have two capacitors here, C1 and C2. So here C1 equal to C2 equal to C capacitance only, C farads only. Okay, then let's start our discussion. Okay, at till t equal to t1, vc1 and vc2 are 0 because there is no voltage, and here I am taking a capacitors c1 and c2 as initial voltages as 0. That means vc1 of 0 equal to 0, vc2 of 0 equal to 0 volt. Okay, at t is equal to t1, what's happening is S1 is turning on and S2 is still turned off. Then if I redraw the circuit, it will look like this. Okay, S1 is turned on and this is a capacitor. This capacitor is C1, and you can say that this is a ground here. This is a voltage V. Okay, because you can say that till t equal to t1, capacitor is not seeing any voltage. At t equal to t1, you can say that the capacitor suddenly is seeing some voltage V. So that this kind of waveform. Okay, this has infinity frequency component which is being seen by the capacitor C1. Okay, so that I can replace. So before going there, right? So I let me tell you. So one thing. So I can say u of t. If I draw the u of t signal, this will be like this. Okay, this is 0, and the signal is suddenly going at t equal to 0 from 0 to 1. Okay, in the same way I can make u of t signal in practically in this way. Let's assume I have a voltage source here and I have a switch, so that I will close the switch at t is equal to 0 till less till t equal to 0. That means minus infinity to t equal to 0. This node is not seeing any voltage. That means this node is 0 volt. At t is equal to t0, because I am turning on this switch, and assume this is ideal switch, I am turning on this switch at t equal to t0. That means the voltage at this node suddenly going from 0 to 1 volt. Okay, let's assume this voltage is 1 volt, so that I can make this step signal by unit step signal or step signal by using a voltage source and a switch. So the same scenario, same concept is being applied here. Okay, let me erase this one. uh, okay, because of same supply, the suddenly at t is equal to t1, the capacitor is seeing this step signal with v volt, and because of the sudden change, the capacitor is seeing high frequency component signals. Because of that one, the capacitor acts as short circuit at t equal to t1, and if I calculate what is the current flowing through the circuit, v by r, and resistor, there is no resistance here, so that v by 0, which tends to infinity. That means infinite amount of current is being flowing through this circuit. Okay, because of that infinite amount of current, capacitor will suddenly charge to v volt. Okay, that means at t equal to t1, we see capacitor c1 will suddenly charge to v volt. Okay, at v volt, and that will stay at v volt only, because that this is the only circuit which is being uh, on from t1 to t2, so that the vc1 will charge keep at v volt only. And if you see vc2, this s2 is still turned off, and this node is not being connected anyway. There is no resistor here, nothing is being connected, and consider it as ideal, so that vc2 voltage will be still 0 volt only. Then let's analyze what's happening at t2. Okay, at time t2. Okay, so if I redraw the circuit, s1 is turned off and s2 is turned on. Okay, let's redraw the circuit. Okay, this is interesting here. okay, this capacitor, and this is the initial voltage at t equal to t2. So let us assume at a t2 the C1 capacitor is being charged with V volt. That's why I am representing it as a separate voltage source, and S2 is turned on, and there is a capacitor here which is C2, and this is C1. And if we see at t is equal to t2, okay, so this voltage is there, and this voltage, the S2 is suddenly again seeing some V volt across this capacitor, and C2 will get short circuited, and you can say that this how this voltage being distributed, how this capacitor C1 charge will get distributed between this C1 and C2. Why? Because this node, if I take this node, right, so this should satisfy KVL. Okay, otherwise this whatever, if I am telling this V volt and it will also go to V volt, no, it cannot go to V volt. Why? Because it's already being charged with some Q charge, and this Q charge only can be distributed between these two capacitors. Okay, so this node we need to know this node voltage. Okay, so we need to balance this charge between C1 and C2. So how this will get balanced based on the capacitance values. Okay, let's find how it will be. Q is equal to CV, and if I rewrite, I can rewrite this C1 and C2 with, if I take this node, right, this C1 and C2 are in parallel, so that I can write C equivalent. Okay, so this will be C equivalent and V. I am saying this is a V node voltage. This, let's assume, let's take V dash, V dash voltage, V dash node voltage. Okay, V dash is equal to C1 into C1 into uh, uh, VC1 plus C2 into VC2. So how? Because this is simply like some charge distribution, so that V dash will be, so C1 is C and VC1 is equal to V volt, plus C2 is equal to C, but VC2 is 0 volt, so that this will become 0, and so that this is 0 divided by C equivalent is equal to 2C, because these two are in parallel. Okay, so that the V dash will be V by 2 volt. Okay, so that at t is equal to t2, VC1 and VC2, this is like this node will be same, so that this VC1 and VC2 will again uh, suddenly come to uh, V by 2 volt. Okay, and this VC2 from, it will go from 0 to V by 2. After this one, the after this from T2 to T3, there is nothing is happening here. These two capacitors are still connected, and there is no dissipation path. There is no resistance connected in parallel. So that the, as this is a ideal, the voltage stays at V by 2 only, both in C1 capacitor and C2 capacitors. This will be same only, constant. Okay, this will also be straight line. Okay, at t equal to t3, again something is happening, because at s2 again it's opening, and s1 is again closed. Okay, for that one, let's remove this small circuit. Okay, if I redraw at s when s1 is on and s2 is off again, this will be same again. This is the voltage source, and this is connected with like this, and there is a capacitor C1, but now it has some initial voltage, okay, which is V by 2 voltage, because here it is V by 2, so that this is C1, and this is voltage, this is ground, this is again V volt. Okay, again the voltage, because S1 is turning on, C1 is seeing again some voltage, sudden voltage. Previously it was at V by 2, and sudden again it is seeing some V volt. It's like some sudden again some seeing some V volt, so that there is a high frequency components. The capacitor C1 again will get short circuited, and if I see what is the current flowing through this circuit, V minus V by 2 divided by R is 0, so that again the current flowing through the circuit is infinity, so that suddenly the C1 capacitor will again charge to V volt at t equal to T3 plus. Okay, so if I redraw this one again at here, uh, C1 is charged to V volt. This is V volt, and after this T3 plus, it's connecting in S1 is only on, S2 is off, so there is nothing is being happening, so that the C1 will stay at V volt only, and C2 will stay at V by 2 only, because uh, there is nothing discharge path, there is no discharge path for any C2 also, so that it will stay at V by 2 only. Now let's see what's happening at t equal to T4. Okay, let's at T4. Okay, at T4 what's happening is this S1 is open and S2 is closed, but C1 now has charged with V volt, and C2 is initial has a charge of V by 2. Okay, let's redraw the circuit. Okay, and this has a voltage of V volt. This is C1. The same way it has C2. Okay, but it has a charge of V by 2, and this is C2. And again I want voltage potential at this node, because this is V and this is V by 2, and if I apply a KVL, this will violate. To satisfy KVL, this charge distribution must happen between C1 and C2. Let's go from Q is equal to CV formula only, so that C equivalent, and this again I will take it as V dash only. So the V dash will be C1 into V1 plus C2 into V2. Okay, I want V dash. Now C1 is C only, V1 is V volt only, because V1 is VC1, V2 is VC2, VC1 is V volt only, but C2 is C volt, VC2 is V by 2 volt. Okay, at T equal to T3, that means T4 minus, and C equivalent will be 2C. So if I rewrite here, the final value will be here. The C, the C will get cancelled, and V plus V by 2. This will be 3V by 2 divided by 2. This will be 3V by 4. Okay, this voltage at this T equal to T4, this voltage will go from V to uh, 3V by 4. Okay, from here VC2, V from V by 2, it will go to 3V by 4. And after this, when S2 is on, so there is nothing is happening. Once the charge distribution happens between C1 and C2, so it will stay here, stay there only, because there is no loss of charge happening. So this will stay here only, and this will stay here only. So if you repeat the same cycle, what will happen is, again when S2 is turned off, S1 is turned on, again C1 will go to V volt, and after that when S2 is on and S1 is off, again the charge will distribute between C1 and C2. The same cycle will repeat. At some point of time, C1 and C2 both will finally charge to some V volt only, because there is no loss in the circuit. Finally the C2 and C1 will get charged to V volt, and that will become steady state of this circuit.